let's go over completing the square. So they've given us this question, what is completing the square? Essentially, we'll talk to it very quickly. We're going to take a quadratic and we're going to take it from what's known as the standard form. Okay, so that looks like this, ax squared plus bx plus c. And we're going to change it to what's known as vertex form, which is a times x minus h plus k. Okay, so we're essentially going from this to this. So we use c, lowercase, completing the square, we'll call it. Okay, so the very first step is to ensure that our question is originally in, this is known as the standard form. Okay, so standard. And like we said, we're moving to vertex. So the equation we have, let's ensure. What form is this in? Do we know? That's standard, yeah. So what would be the a value in this question?
2.
Perfect. And what would be the b value?
12.
Okay, and the c value?
-3.
-3, good. It's important to use that operator also. Okay, that's going to be important because of our next step here, completing the square. Now, just to point out, we're actually going to show you how to use a formula after to do it. We'll first stick to what you're used to, and then we'll show you how we can get the same answer pretty quickly if we have a little formula here.
Okay.
Okay, so we have our standard form. The very first step is to actually divide the first two terms, or common factor the first two terms, by the a value, whatever that a value is. Okay, so in our case here, our a value is the number 2. So we're dividing both of these terms by 2. Essentially, we're common factoring out that 2. Okay, so 2x squared divided by 2, well, that's like creating a 1. We're left with just x squared. And that's the whole point. We're trying to create the coefficient of 1 in front of x squared here. Okay, plus 12x divided by 2, well, that's 6x. Perfect. Okay, so that's our very first step. We leave our -3 out here on the outside. Now, the next step is we take our new b term. So our original b term we said was 12x, but after we've factored out this a, we can call this our new b term. Okay, maybe you call it b subscript 1, just so to know that it's different. Don't worry about subscripts. That's something you do later in math. But here's our new b. So we put it through a little formula where we say b divided by 2, and then we square it. Okay, so our b value is 6. Okay, we're just taking the coefficient, so 6 divided by 2. And according to BEDMAS, we do what's in the brackets first. Okay, so 6 divided by 2 is 3. And then 3 squared is equal to 9. Great. Now, what we're going to do is we're actually going to take plus or minus 9. Or we're going to add and subtract 9 in these brackets here. Okay, so we're going to take its value. Okay, and we're going to put it back into these brackets. So y is equal to, now I'm going to get a color, 2x squared plus 6x. So notice all these terms are still the same. I haven't changed anything. But what I'm doing is I'm going to add and subtract. Yes, all within that bracket. Subtract 3. Now, why can I do that? Well, the reason I can do that is because what's positive 9 minus 9 equal? 0. So that's like adding 0 to the equation. And no matter where we add 0 to an equation, it's not going to change the equation. I don't know whether those came as 10s. That should be pluses. It's not going to change anything. Okay, so we're going to add and subtract it. It doesn't change anything. But what it does do is it allows us to start factoring this middle term a little easier. Okay, so to get this middle term, we're trying to make it a trinomial. A trinomial is when we have just 3 terms. Okay, and right now there's this 4th term that's kind of bugging us.
So you go outside the bracket.
Exactly. The only thing is,
The 2.
yes, when we move it outside the brackets, we have to multiply by the coefficient. The reason being is, if you remember, when we're doing expansion, you have to multiply or distribute that term to everything. So if we're pulling something out of the bracket, that 2 has to be distributed to that term. Okay, so we take that 9, and we're going to multiply it by our a value, our new coefficient. So we're going to multiply -9 times 2. So our next line is going to read, everything else is the same, 2x squared plus 6x plus 9. And then outside the brackets, -9 times 2 is going to be like -18, and we still have -3. Great. Okay, so now we can simplify outside the brackets if we want. we'll do that as the next step. Y is equal to 2x squared plus 6x plus 9. This becomes negative 21. The last step we're going to do is we're going to factor this trinomial we talked about with making. Now, this isn't any trinomial. In fact, the entire process we did was to make a very specific trinomial. This trinomial is considered a perfect square trinomial. Okay, so what's neat about perfect square trinomials is there's actually a really fast way to factor them. We can take the first term, okay, that's our, call it our x squared or 1x squared, whatever we want to do it, and we can square root it. That's the first term. And we can take our last term and square root it. When we square root these, square root of 1x squared is going to be x, and the square root of 9 is 3. Okay. For what we're going to do here, we'll leave that 2. And this bracket actually becomes one bracket with just 2 terms now. It's a very quick way of factoring. We take the first square root, that's the first term. We take the last square root, that becomes the second term. Okay? And whatever the operator is in front of our middle term, that positive sign, that becomes the operator down here. Okay? And that's it. It's actually been factored. So if this is hard to remember, you can always go through your sum and product. I'll do it really quickly on the side. Let's bring down our negative 21. Technically, we're in vertex form now. We've completed the square. Just as a side note, I know we kind of cheated our factoring by these little square roots, but just to show you a sum and product, okay, we take 2 values that multiply to the last term, right? So 2 values that multiply to 9, and the 2 values have to add to 6. Well, look at this. Our 3 value, 3 times 3 is 9, and 3 plus 3 is 6. Great. So when we go to factor that, we have x plus 3 and x plus 3, but instead of writing it twice, we write it once to the power of 2. Okay? So instead of having to do that every time, you can just kind of square root your answer. But we got to our vertex forms, that's completing a square, but there's actually another way to do this. These little formulas. Now, I know we kind of have to have them memorized, which can be very annoying. I'm going to put these together so I can move them really quickly. Bring it down to the bottom. Actually, you know what we'll do? We'll go to a new page. Here we go. So, let's paste our little formulas here. And our original equation stated y was equal to 2x squared plus 12x minus 3. Okay, so we already know we're in standard form. We talked about that. These formulas refer to standard form. And when I say x, when I say the word subscript, it means I'm writing a little letter to the bottom right of it. I'm saying the x value of the vertex, okay? And here I'm saying the y value of the vertex. They're also known as your h value and your k value from vertex form, okay? So if I want to find the h value, I can actually just plug a formula in. In fact, I'll say h, or x value of the vertex, is equal to negative b. And remember, we have to decide what these values are. And this is c, okay? Well, our b value is 12, so I'm going to say negative 12. Give me 1 second. So like we're saying, we get the b value, which is 12. If it was negative 12, this would actually be minus negative 12, okay? And that's going to be divided by 2 times, well, our a value is 2, so it's 2 times 2. So our h, or x value of the vertex, is equal to negative 12 over 4, which equals negative 3. Okay? Good. That's our h value. Our k value. K value, or the y value of the vertex, is equal to our c term, which is negative 3, minus our b term, which was 12. Okay, and then we got to square it. And then I'm going to put this in green, just so we kind of correlate with our colors above. Divided by 4 times a, and a is the value of 2. So let's do that exponent first. 12 squared is actually 144. It's a pretty big number, 144. Divided by 8. 8 goes into 144. Oh, how many times now? 168. 7? Oh my gosh. My multiplication tables are very rusty. boom. 18. Why was I thinking? 64. Oh, 68. That makes sense. Okay. 18. Negative 3. This divides into 18. Okay. But we still have our subtraction sign here. So it's negative 3, which is going to be negative 21. Okay. Great. I got two values. How do I build vertex form? Well, remember maybe the parent function or the original vertex is they use these letters to replace. We have a, x, minus h squared, and then plus k. Well, let's take our values here. Our h value, this is a good example for an h value, it's negative 3. So we're going to replace h with negative 3. Y equals a x minus negative 3. Okay, so because it was a negative, it's a minus negative 3. Our k value is negative 21, so let's replace k with negative 21. Okay, this becomes y equals a x plus 3 minus 21. Those two values are right. What about our a value? What do we do? Well, it's really easy because the a value is always the same in all those methods, so it's just the number 2, the a from above. So it becomes 2x plus 3 squared minus 21. And if you remember, when we take a look at the two sheets here, that's the answer we got for both. So this would be using completing the square, and this one's using a formula. It ends up being a little quicker, the formula, but the only downside is you have to kind of memorize that formula.